Hi guys, you're welcome to God Academy, and we continue with our second session for calculus with analysis. If you missed the first one, please make sure you first subscribe to the channel, then you visit the previous videos, make sure that you are in track. So in this lesson, I'll be taking you through absolute value problems, then you go into functions. You may not be able to finish the function because function is plenty. That will mean that you're going to join us in the next session. So please stay glued to your seat and watch this video to the end. Recommend to your friends whom you think is going to be helpful as well. Okay, so in this lesson, as I said, absolute value problems. In our previous lesson, we saw that neighborhoods is simply creating intervals around the point. Is that not it? And we came out to derive the formula x minus c is less than or equal to the delta, which is the radius, right? Where c is our center, like this. So with this expression derived, we are going to apply this to solve our absolute value problems. So here you realize that the solution, or to create an interval from here, we simply going to have c minus lambda comma c plus what? Lambda, right? Sorry, delta. So this is the interval to be created. Since this one is less than or equal to, this one is for you're going to have this c minus this comma c plus this. Now let's make more sense. Our first problem one, it says that absolute of x plus 3 is less than or equal to 5. Absolute of x plus 3 is less than or equal to 5. Okay, so to solve this problem, definitely you know that you're going to have, we are just going to find our c, as well as you're going to find our radius, right? So here was our c. Our c is simply equal to, so our c is simply equal to negative 3, if you can see clearly, right? Then our delta, which is our radius, is going to give us 5. Then you come here, let's check something here. So meaning that our solution, our interval, is simply going to be c minus what? Lambda. That will be negative 3 minus 5 comma negative 3 plus what? 5. And what does this give us? We get negative 8 on the lower term, then we get 2 on the upper term. So this is how we solve absolute value problems using the neighborhood approach. Now let's go the mathematical approach. Whenever you have any absolute expression, remember that the output can either be positive or what, or negative. You should know that. Therefore, we can say that you can either have x plus 3 is less than or equal to 5, or negative of the expression x plus 3 is what, less than or equal to what, 5. You should know this. Because of that, we simply conjoined it and we bring out an expression as x plus 3 is greater than negative 5, less than what, greater than or equal to negative 5, less than or equal to 5. This will merge all the two scenarios. So once the two scenarios are merged, we're going to solve. So I'm going to have negative 5 minus 3. You can obviously see that it's less than or equal to x. It's less than or equal to 5 minus 3. So this gives negative 8 less than or equal to x, less than or equal to what, 2. And obviously that's the same answer we got here using the neighborhood approach. Therefore, in the interval notation, this becomes negative 8 comma 2. That is all. So first question solved. Let's go to the second question. So similarly, we are going to have 5 minus 3x less than 2. So with this, well, I think you can go by any of the approach. Let's use the mathematical approach and move on. So using the mathematical approach, as I showed you, you're going to have 5 minus 3x is greater than negative 2 and it's less than what? 2. Solving this mathematically, you have negative 3x going on the left side or what? So here, please, whenever you are solving um, absolute value problems and you have something like this, you treat this as 1, this as 1, if it's going to confuse you. Okay, so if this is going to confuse you, break it into two parts. You have negative 2 less than 5 minus 3x as 1, then 5 minus 3x less than 2 as second. If not, and you think you can go by the approach, then you simply do for both sides at the same time. So here we are going to make sure that we make x the subject. That's the goal. First, we have to get rid of this 5. So we have negative 2 minus 5 less than negative 3x powerfully less than 2, then minus 5 as well. So this is negative 7 less than negative 3x less than what? Negative 3. Is that not it? Then what do? We divide through by the coefficient of x. And since you are dividing through by negative, meaning that our sign is going to reverse. So this is going to give us 7 out of 3 greater than x greater than what? 1. And that becomes our answer. Like this. That becomes our answer. So s is greater than 1, while 7 out of 3 is greater than x. Hence, in an interval notation, open 1 comma 7 out of 3 close like this. So I hope you are getting it as we solve a couple of problems here. Let's solve this beautiful problem. X plus 1 is less than absolute of x. So this one, I'm moving you away from the neighborhoods application. Okay, so this one is a little bit brain teaser of a sort. So you have x plus 1 less than absolute of x. So to solve this problem, what do you need? Where is your absolute? It's on my right side. So this can act as positive or negative. So there are two case scenarios here. For case 1, I'll simply say that where x is greater than or equal to 0, then you're going to have x plus 1 less than x. But what happens here? You're going to get x minus x is less than negative 1, which is 0 less than negative 1. And this is impossible. It's literally impossible. It's not true actually. So we don't buy that. Then we check the second case. So for case number 2, which says that we're going to have where x is less than 0. So if x is less than 0, then it means that I'm going to have x plus 1 is less than negative x, obviously. So what happens? So here I'm going to have x plus x on the left side less than negative 1, 2x less than negative 1. Therefore, I'm going to have x to be less than negative 1 out of 2. Beautifully, right? So we move to the next problem, which is question number 4. So as we move on, please, if you are here and you haven't subscribed, do well subscribe so that you become part of the family and you get updated directly whenever there is a tutorial of it. So please do well to subscribe. Okay. So let's solve one beautiful question here, which says that absolute of 1 over x minus 2 is less than 4. So this problem is going to be easy, but a little bit tricky. So it resembles what we've been doing, is that not it? So first of all, as I said, mathematical approach, what are you going to do? You first write to eliminate your absolute sign. You have to make sure that you put the positive and negative of 4. So negative 4 less than expression 1 over x minus 2 less than not 4. Is that not it? Yeah. So with this in mind, you can clearly see that if you add this, I mean, the goal of our work is to make x the subject. Obviously, that is what you want to do. Is that not it? Obviously, that is what you want to do. So we're simply going to have negative 4 plus 2 less than 1 over x less than 4 plus 2. This gives me negative 2 less than 1 over x less than 6. At this point, this is where the problem comes in. Now, if you have an expression of 1 over x, remember the x here can either be greater than 0 or less than 0, but can't be 0. Why can't it be 0? Because it will give an undefined expression which is not allowed or acceptable in mathematics. For that reason, we are going to continue solving in cases. So for case 1, where x is greater than 0, we're going to have the expression negative 2x less than 1 less than 6x. Obviously, you understand, right? We take the positive part. Taking the positive side and you are solving. As I said, if it will confuse you, break it into two. One, negative 2x less than 1. The other one, 1 less than 6. Nicely. If you don't want any problem. Here you are simply going to have x is greater than negative half. Why? You divide through by negative 2. Whenever you are dividing or multiplying a negative across a sign like greater or less than, it will switch or reverse the sign. That is why you have s greater than negative half. On this end, simply have 1 out of 6 is less than x. Is that not it? So I have 1 out of 6 is less than x. With this expression in mind, ask yourself that I have two answers. So please, you do some kind of analysis. You don't just write the answers and you are done. X itself is greater than negative half. And here too, please, when I rewrite this, it's the same as S is greater than 1 over 6. So if you are telling me that S is greater than negative half and S is greater than 1 out of 6, I don't know if you're getting it. Meaning these answers can be merged. We simply do illustration on this number line, right? Let's say negative 0.5 is here. That is the negative half, right? 1 over 6 can be 0. Let's say what? 3, right? So let's say it is somewhere, let me say somewhere here, 1 out of 6. If they are saying that from S like this is the half, and this one is from here like this. The question is that whenever you have a value, whenever you have X being greater than two things, let me say it this way. So now let's say I have money in my pocket. That money is greater than 5 cedis, right? If that money is greater than 5 cedis, obviously it will be greater than 1 cedi. I don't know if you get it. So if I have X being greater than 1 over 6, it will obviously be greater than negative half. I don't need to repeat this one again. So this one is merged inside. Therefore, the case one gave us only one correct answer, which is what? The X is greater than. This one is the correct. This one can be found here because if something is bigger than a bigger number, it is also bigger than the smaller. Beautiful. Let's move to the second case, which is the second case, case 2. For case 2, obviously when x is less than 0, what happens? You reverse the signs. So I'll have negative 2x greater than 1 greater than 6x. The same applies. I have negative 2x greater than 1 on one side, 1 greater than 6x on another side. So here I'll have make x the subject. Dividing through by negative is the sign or to reverse. So I have x less than negative half. Then here I'll have x less than 1 out of 6. There come again another decision to be made. So this is one solution. This is another solution. With these two solutions in mind, then we are going to have um, the conditional assessment. So with this assessment, you're telling me that x is less than negative half. X is less than 1 out of 6, right? So you ask yourself, is something is smaller than two things and one is bigger and one is small? Obviously, if it's something is smaller than a smaller number, it is smaller than a bigger number, right? So if I have two cities is smaller than 10 cities and smaller than 100 cities. There is no need for me to say that the two cities is smaller than 100 cities and at the same time smaller than 10. It doesn't make sense. If I say two cities is less than 10 cities, it's enough to cover 100 cities, right? So we always use the lowest term when you are on the left side, that is on the negative side. So here you say that x less than negative half, it makes more sense or is correct because this can be found here. Therefore, our answer to our absolute value problem is simply x greater than 1 out of 6 or x less than negative. Beautiful. Let's solve our final question for the absolute value problem and go and solve more problems on your own side. Good. So I have a beautiful problem here. says absolute of 3 minus x equal to x minus. Now, I believe that most of you, if you are to solve this problem, you start by opening this and all that. Please, in absolute value problems, don't jump straight solving. Sometimes you need to try and apply. Most questions, if you rush and solve, you waste time not knowing that the answer is either no solution or you can even use your eyes to tell the answer. So don't be in rush. You have 3 minus x and you have x minus 3. You are saying that the absolute of 3 minus x is the same as x minus 3. Is that not the reverse form of this? So there is this. If you have an absolute of u and it's giving us negative u, what does that mean? It means that u is less than or equal to 0. I don't know if you're appreciating it. Whenever you have the absolute of any number and it's giving a negative answer, it means that number is less than 0. With that in mind, then we can say that instead of me solving everything, I just take my answer in this bracket. So I'll say 3 minus x is less than or equal to 0. Therefore, I'll have 3 less than or equal to x. And that is my answer. So here, I didn't write the interval notation. So if you want to write the interval notation for this, what are you going to get? Are going to have, if s is greater than or equal to 3, x will start from 3, and we use an angle bracket, comma, infinity, positive. Every infinity, we use an open bracket like a curve one. So please take note of that and don't make that mistake. On this note, if you want to solve, you're going to solve plenty problems, but let's stay here and move to the main agenda for this session, which is functions. Okay, good. Functions. So in calculus, you are going to deal with functions a lot. Like everything you're going to do is a function. Differentiate a function, integrate a function. You try to create a function and analyze it, finding the domain, a range of everything is a function. Remember that in calculus you are dealing with what curves a lot. Okay, curves. So a curve is a function. So without knowing function, how do you start calculus? And these are functions with only one variable, so it should be very simple for you to know. What is a function? What does a function mean? When I say a function is simply a black box, and this black box, it takes an input, right? This black box takes an input here and brings out something which we call an output. In mathematical term, I'll say that it takes an input x and brings out y. Meaning that whenever you have a function, okay, what the function is trying to do is you put in a variable, and the function will massage it according to what the function is supposed to do. So in programming, we say that a function performs a particular task. So anytime you call that function, it executes according to the instructions encoded within that function. Let me use a simple scenario. Y is equal to 2x as a function. I take in my x value, and this function, what it is doing is to multiply my value by 2. So when x is equal to 1, you realize that my function y will be equal to what? When s is 2, it will be 4. So our function, the major goal is doing is to multiply whatever I give it by 2. That is all. That's why I say it's a black box which translates an input to an output. But wait, a function may take in several inputs. So input 1, input 2, it can take in input 3. But take note, a function will always give out one output, like only one output. So a function, every function in this world is designed to give out a single output, but it may be a function of several variables. Maybe I may take temperature, I may take your BP, I may take your different stuff. But the goal of that function will simply predict whether you are sick or not. So to just say this person is normal, this person is not normal. But it may take in several variables. That is why we have many to one function and we have one to one function. So these two things should explain to you that a function will always give one output. Sometimes they can give you a very complicated question, okay? Not knowing that that whole question given to you is invalid because it is actually not a function. You get to understand as you move along, okay? So let's see. So having explained function, we go straight to the properties of function. What do we need from a function? What are the characteristics of a function? There are some three parameters I'm going to talk to you about. The first one is what we call a domain of a function. Talk about what we call the codomain of a function. I believe these stuffs are things you learned before, but interestingly, most of you may either forget, um, maybe you might have forgotten it, or probably you don't even understand it actually. Yeah, it happens. So these are the three king cons that we're going to break it down at this point. What do we mean by domain of a function? Domain of a function is simply a set of values. I'm not doing English tutorial, so I'm not going to be writing definitions here. So I'll be saying it. I'll just be using some representation here. Okay. So domain of a function is simply a set of values that make a function defined. That is all. So given the function all the values in but that will make this function valid. Take away anything that will break down our function or that will make our function invalid. Whatever is left is called represented normally df. Okay, when you see df, like domain of the function. Codomain. Codomain is a set of all possible output of a function. So if I have a function, a set of possible output of this function, like any number that is capable of coming out of this function is called codomain. Okay, so our codomain of a function is simply a set of what the possible, the word is possible, take note, possible outputs. What do you mean by range? Range is actually a subset of codomain. So range is a set of assigned outputs. So let's see something. Now, if I have a function y is equal to 2x, right? We remember you can see that there is no value in this word that will make this function undefined. Therefore, the domain of this function is what? All real numbers. The codomain of this function too says that there is no way this function can give any other output aside real number. So you say that the codomain is also set of real numbers. Then what will range say? Range is a set of successful or assigned output. I can get range over a particular domain. Given x be 1, 2, 3, and 4, then my y will give me what? 2, 4, 6, 8. Therefore, 2, 4, 6, 8 is our range. Okay. Although 2468 is part of the codomain, but codomain is the entire output possible. So this is possible and this is successful, right? Yes, possibly you are it is possible for you to be a successful student or it's possible for you to be a first class student, but your outcome becomes your range. So if it happens that you graduate with second class, then it means that that was your range. But possibly you could have become what? A first class, you could have become a third class, you could have that is a possibility. So the entire possibility is simply your codomain. The range is the outcome. So after all, what happened? Yes, you could have done this, could have done that, but what did you become? That is your range. Perfectly. Having explained this, you move straight to the types of function we have. And the first type of function I'll talk about is what we call constant function. Constant function. When you say a constant function, this is a function that gives a constant output regardless of the input, as the name denotes. So there is a constant output regardless of the input. That is the keyword. Like constantly, it gives one output. Whether you put in anything, it will give you one output. A function f r such that r is a member of all real numbers where x maps to c is said to be a constant function. Example, f of x is equal to c. So here, if I put in f of 1 is c, f of 2 is c, f of 3 is c, whatever is c. Okay, so let me draw it here. I have this nice diagram. I have negative, let's say 4, negative 3, negative 2, negative 1. 1, 2, 3, 4. Remember, most of your domain always lies on the hot x. Okay, then your codomain lies on the y. So 1, 2, 3, 1, 2, 3. Now, let me give you a particular function. Let's say a function y is equal to 2. So this function, the y output is 2, regardless of the input. Therefore, our function will be drawn like this. Take notes. Draw it this way to pass through like good. So the implication is at point negative 4 is 2. Point negative 3 is 2. Up to point 3 is 4. Everything is 2. That is what you call a constant function. A constant function. What are we interested in here? We're interested in what? Finding the domain, range, and the codomain of a constant function. So let's start with the domain. So the domain of a constant function is simply going to give us what? A set of all raw numbers. That there is no number that will make it find. The codomain obviously will simply also equal to what? Set of all possible raw numbers. You know, the thing is, whatever you put in is giving you a constant output. So there is no value that can come out that will make it. So codomain is a set of what? R. But what is the range? Ask yourself. The range is the outcome, and the outcome is what? C. So in this case, our range is what? 2. Simple as that. Let's move to our second type of function called a step function. I think this is learning calculus. Step function, not taught in high. A step function, as the name denotes, is like step. Call it staircase, like staircase, steps, as you know. A step function. If I have a function x mapping to f of x equal to 2, 1, negative. If x is less than or equal to negative 4, if negative 4 is less than x less than or equal to 0, then negative 1 if 0 is less than x less than or equal. Okay. So if I have this function here, this is what we call a step function. Please, what we are learning today is a build up. Like every step is a build up on the what. So here you realize that we have talked about what constant function. The next what step function. A step function is simply a build up of what a constant function. If I give you a constant function and I break it into, we get what we call a step function. So look at this function. This function is saying that all s values which are less than negative 4 gave 2. All values between 4 and 0 gave 1, and all values between 0 and 2 give for negative. Let's draw this. On my x, I'm supposed to have negative 4, negative 3, negative 2, negative 1, 1, 2, 3, 4. On my y, I only need the 1 as an output. Now let's draw this step function. So where is 2? When s is less than or equal to negative 4, meaning from negative 4 here backwards gave us 2. So we come here. So 2 start from here and it move this, which is a constant function, right? The next one is from negative 4 to what? 0. So from negative 4 here up to 0, we are going to get what? 1. So meaning that 1 will start from here, then it will move up to this side nicely. Then the next thing is from 0 to 2. So from 0 to 2, what's the output? Negative 1. So negative 1 is here. So from 0 to 0. So see the steps. So we have step 1. It's like you move from here 1. Ideally, this should have been a straight, and we've broken it into pieces over different what intervals. That is why we call it step functions. I think we should get this for explanation. Now, what do we need again? We need what you call the domain, the codomain, the range. Mostly we don't even need codomain. Our interest is the domain. Remember, codomain is all the possible outputs. So our interest mostly not in there. So what's the domain of this function? A set of all input that make this defined. Whenever they give you a step function, you want to find the domain. Please don't think too wide. You just come straight to the intervals. This is what was given to you. So this is what you do. You write the interval form. So what's the interval for this? To start from any number less than or equal to a negative 4. Meaning the negative 4 is the biggest number. Start from negative, comma, negative 4. Then you close. I told you that this is for what? Greater than or equal to or less than or equal to the rectangular one, and the curve one for when it is what? Less than or infinity. There is no infinity, you have to put this. Infinity is not closed. Yeah, when we come here, it starts from what? 4 to what? 0. Okay. So we're gonna have open negative 4, comma 0. And when I come here, I have from 0 to what? Right? 0 to what? 2. Therefore, my domain, which should cover the entire function. There are three separate domains, so you have to combine them. Combining this, you start from the negative, the smallest here to the biggest. Therefore, my domain for this function is simply negative infinity, comma 2. That's all. Ticked. What is our range? Our range is the output. So our range is as simple as what? ABC. So 2, 1, and negative 1. And that is all for step function. Let's look at a beautiful scenario here. What we call a non-step function. It may deceive you. So with a non-step function, our interest here is to see some functions which appears to be a step function. Have a function g, r, which is a member of all real numbers, where x points to g of x is given as 2, 1, negative 1, is 2 if x is less than or equal to negative 4, if negative 4 is less than or equal to x less than or equal to 0, then if 0 is less than x less than or equal to 2. Now, is this a step function? Let's critically analyze something. So let's see. I want you to spot the difference here. You are telling me that for x less than or equal to negative 4, our output is 2. You came here again and you are telling me that when s is greater than or equal to negative 4, therefore that is the difference here. Meaning that negative 4 is being assigned 2 and what? 1, which disobeys the concept of function. Function does not give true output. Therefore, they are saying g of negative 4 is equal to what? 1, and which is invalid. Therefore, this is not a function. So whenever they give you this, you may be tempted straight away going to solve, and please you realize that it's actually not a function, and everything you're doing is yes. Good. Let's move to the next type of function. So I move to the next page, and I have my next type of function called piecewise function. Wise function. So when you talk about piecewise function, a piecewise function, as the name denotes, is a function in pieces. The other one was in steps, but this one is in pieces. It's like a normal function that we have broken it into several pieces. Let's see. F R, which is a member of all real numbers. I'm going to have x pointing to f of x, which is equal to x plus 2 negative. If s is greater than or equal to 0, you have 2x plus 2 if x is less than 0. With this thing here, okay, this is what we call a piecewise function. So a function which has two pieces, negative x plus 2 is a line, 2x plus 2 is also another line, and they are defined over two different ranges. It's a single function but broken into because it is defined over particular domains. Okay, so this function, when you draw it, will look like something like this. Something like this. One is negative and one is what? Positive. Now, as I said, our goal is to find the domain and the range. So what's the domain of this function, of this piecewise function? Whenever they give you a piecewise function, you want to find the domain, please look at the trick. The other one was step function, so we use directly the output here. Oh, sorry. This is domain, right? So finding the domain, we always use here. This domain, we always use what we have here as our domain. So now let's do it. So here, what do we have? S greater than or equal to 0 means that you start from what? 0 to what? Infinity. So 0, comma, positive. When I come here, s less than 0 means that I'll move from negative infinity to what? 0, like this. Therefore, when I combine these two, I'll have from negative infinity to what? Positive infinity, which is the same as all real numbers. As that. So the domain of this piecewise function is a set of numbers which are all members of the real number, them or whatever. Now, what's the range? Let's analyze the range carefully because finding the range of piecewise function can be a little tricky. So please, let's check it very well. Okay, so for the range, I'm going to have this side. You massage your domain to get your range, okay? Now, for the first one, if x is greater than or equal to 0, what are you getting? Negative s plus 2. How do we modify this to get negative s plus 2? I'll first negate it. This will give me negative s is less than or equal to 0, right? Then I'll add plus 2. Negative s plus 2 less than or equal to 0 plus 2. Therefore, negative s plus 2 will be less than or equal to 2. So we can clearly see that negative s plus 2 will give an output which is less than or equal to what? 2. So we say that from 0 like this, right? Sorry, from negative infinity, from negative infinity what 2. We come again for the second part. I have x is less than 0. How do I modify to get 2x plus 2? I'll first multiply through by 2. 2x is less than 0. I'll add 2 to both sides. 2x plus 2 is less than what? 2. So here you can see that it's the same thing starting from negative and open. But since this is closed, we take the bigger one. Therefore, the range is simply negative infinity equal to 2. Safe. And that is all for piecewise function. The next type of function I'm going to take you through is what we call power function. Power function. Power function. When you talk about power functions, what they are trying to say is it's a function which is represented as f of x is given as ax to the power p. Ax to the power p, where a is a member of all real numbers minus 0. In functions, please, in calculus, we'll be seeing this a lot. R minus something, it means that excluding 0, okay? So a is a non-zero term, but it can be any number. P is a member of all real numbers. Can be 0, can be anything. Now, there are different types of power function depending on the value of P. If P is a member of all positive integers, we get what we call a monomial. A monomial. Example, if you have 2x squared, if you have s cubed, we call it a monomial. A monomial. Okay? A monomial. So a monomial is simply a power function where p has a power as a positive integer. The second type is if p is a member of negative integers, we get what we call reciprocal function. Reciprocal function. Typically, we can have 2x to the power negative 2, and you know that this is equal to what? 2 over x squared. This is what we call a reciprocal function. Again, if p is a member of a, a rational function or 1 over n, where n is a member of what? Natural numbers. So if p is a fraction, it means that we are going to get what we call a radical function. Radical function. Example is square root of x, which is x to the power 1 out of 2. So please understand that power function is actually a template Within power function, we have three main types: monomial, we have reciprocal, then we have radical functions. Well, which are all types of what? Power function, which you should take note. Then we are going to have the domain and the range of a series of power functions. Okay, so I'm going to have my first function f of equal to x to the power 2. What is the domain of this function? What is the domain of this? Find the domain of this function. You can clearly see that there is no number on x here. That when you put it here, you are going to get what you call. So let me draw a table. So this is domain and this is range. So realize that there is no number that when you place it inside X, you are going to get undefined. Therefore, our domain is simply a set of all raw numbers. What will be the range? This here is x to the power 2 times n. There is no way this can give a negative value. So our range will be a set of all positive raw numbers. Take note. Set of all positive raw numbers. The second function is going to be x to the power 2n plus 1. If we have x to the power 2n plus 1, what would the domain be? Obviously, the same thing, a set of all raw numbers. And what would the range be? You can see the plus 1 here can make us either get an odd. We can get an odd. This here is odd, right? Since it is odd, we can end up getting negative output. Therefore, it is a set of all raw numbers, not positive or non-negative. Okay. Let's go to the third function. For the third function, we have 1 over x to the power 2n. What is the domain of this function? Is there a number that can make it undefined? Of course, yes. When s is 0, everything is 0 becomes undefined. So our domain is r minus 0. As simple as that. Our range, because it is power 2n, will always give us positive. So r plus minus 0. We can't get 0 at all. And that is nicely done. Then we come straight to the next 1 over x to the power 2n plus 1. Of course, I think you can relate that this will simply give us r minus 0, and this will give us r minus 0. Let's try one radical, and one radical will give us 2nx. So when I have 2n with s, which is also the same as x to the power 1 over 2, you can see that here what will be the set of our domain. You should be very technical. You've done algebra, and you should know that whenever you have the square root of a negative number, you get a complex number. So we get rid of all negative values. Therefore, our domain is r plus. What should be the range? Range of can't get negative, can't fit it. That is all I'm going to touch on in power function. Let's move on to polynomial function. I think this one is too familiar. I'm not going to touch on it. Polynomial function. And the polynomial functions, you see that a function f of x, which is equal to a naught plus a1x plus a2x squared in that order. Any function in this form is what we call a polynomial function. A itself can be 0, can have f of x equals 0 to, yeah, that is also called polynomial. Then we can also have this. So given a function f of x which is equal to 1 out of 2 plus x squared, let's find, this is a polynomial function. So let's find the domain. Let's find the, what will the domain of this function be? You can clearly see that the domain of this function is going to be a set of all real numbers. There's no number that will make this undefined because it's x squared, right? The domain is R. What is the range of this function? Find the range of set of outputs. We need what we call the smallest number and the largest number to give us the range of output. So the least number this can ever attain is what? 1 out of 2. Because the squared here can never make it negative for you to deduct. So here we're going to have 1 out of 2 like this. Sorry, included. Comma, the highest number is infinity. So this is, sorry, never use those for infinity. So this is the range for this polynomial function. We also have a type of function called rational function, which I know you've played with before. So rational function, as usual, is stated as a function f of x given as q of x over r of x, where r of x is not equal to 0. As simple as that. That is a rational. So for rational functions, it's a little bit tricky. If you want to find the domain, it's the popular ones you've been solving in high school. So if I give you something like 3x over x cubed minus 1, know that to find the domain is a set of numbers that make this, that will give us what? X cubed minus 1 for 0. This will obviously give us what? For s, which is 1, make this one different. Our domain is simply r minus 1. As simple. Where the range is also going to be what? So after, once you put everything inside without 1, your output should be a set of what? All raw numbers. So let's talk about algebraic function. Algebraic function. Algebraic function. There are so many types of functions. So we're going to cover some part today. See you in the next session. Please don't miss. And if you're not subscribed or if you just joined, please do also subscribe to be part of us so that you don't need to be informed directly, but you just get notified for ease, your own benefit. And if you think that you find it okay, algebraic for algebraic expression, I'm going to have something like sums, products, or quotient of a polynomial. So when you talk about algebraic expression or algebraic function, you are trying to say that when I have polynomial function and I add, so if I write x plus 1 over x, this becomes an algebraic function, whilst s itself is a polynomial function by x. So that is it. So giving f of x, which is equal to the square root of 5 minus 2x, then you are going to have the domain be any term that will make this when you take it out. And remember that everything under this should be greater than or equal to 5 minus 2x greater than or equal. Therefore, 5 will be greater than or equal to, therefore x will be less than or equal to 5 over 2. Therefore, half our domain r minus 5 over. So please don't be writing minus 5 over 2 in some cases. Mostly just write that x is such that x is a member of all real numbers where x is not equal to 5 out of 2. That is all. So stating this wouldn't be so hard. Don't be writing r minus. The exams use appropriate going to do so. Now let's try one more problem here. So we have root of x minus 1 over x minus f of x equal to root of x minus 1 over x minus, right? So this means that we are simply going to find the values that make this fine. So finding the domain of this function. First of all, you know that square root of x will never accept a negative value. So x should be greater than or equal to 0, or x should not be equal. Then you know that x minus 1 here should never be great, never be what? Equal to 0. So it should be greater than or equal. It should be greater than 0, sorry. Therefore, x should be greater than 1. We can see, right? So it's a set of what? All real numbers where s is not equal to 1 minus 1 minus what? 0. Interesting. Say that x is that x is member of all real numbers where x not equal to 0, not equal. So that is all for algebraic expression. And thank you for being with us in this session. We'll continue next time, which is our next day 3, is going to be on transcendental function, odd and even, touch on a lot bounded and some beautiful stuff. So please stay glued to your seat. Anytime you get a notification, bell ringing in your ears that there's uploaded or live schedule, please be in hurry to join so that you get the permit. Thank you. Thank you. See you. Bye bye.